An object is defined as a thing that exists in the real world. And most things that are recognized as a noun are called objects. Now, objects can be physical objects, like these examples we have here, or it could be conceptual objects, like these examples we have here. Now, objects can be represented by classes, particularly Java classes. A class or a Java class has two key aspects. These two key aspects of a class are, first, behavior, and second, state. Behavior of a class are represented as methods, and the state of a class are represented by fields, and these are values held by a class. So say for example, if we define a vehicle class, the two key aspects of this vehicle class are its behavior and state. The behaviors of vehicle class are the following. It can run, it can stop, it can accelerate, it can carry, and many other things. So behavior refers to actions of a class, or what the class can do or can be done, or what the computations are in the class using the class. So behavior are verbs or actions. So what the vehicle class can do is it can run, it can stop, it can accelerate, it can carry, and other things. The behaviors or the actions of the class refers to as the methods of the class. For the second aspect, which is the state, these are, as mentioned here, these are values held by a class. So the vehicle class has a body color, has fuel amount, has status of engine, has total weight that it can carry. So state are simply descriptions about the class or the object that the class represents. So states are those descriptions of the object that the class represents, while behaviors are those actions or verbs that the object that the class represents can do or can be done to the class, or what are the computations that are involved in the class. So again, a class or a Java class represents any object in the real world, or an object in the real world can be represented by a class or a Java class. So a Java class is simply a definition of a real-world object. And this has two key aspects. What are the two key aspects of a class? These are the number one, behavior or behaviors, and the state or states of the class. So the behavior refers to the verbs or the actions, what the object can do or what can be done to the object, or what are the computations that can be done using the object. While state of the class refers to the descriptions about the class, like what is its color, what is its height, etc. So a class is a definition of an object, while instance is the actual entity of the object created based on source codes. It holds actual values and performs processes. So an instance of a class is an actual entity created based on the class definition. Now, since class is just a definition, it has no memory or RAM allocation because it is not an actual entity, while an instance is an actual entity. Just like a variable, it has RAM or memory allocation. Okay, so a class is simply a definition, no memory allocation, while an instance is an actual entity like a variable that has memory allocation. Recall, in C programming language last semester, we discussed about structure, right? When you are going to employ structure in your C program, you need to have a structure definition first, and second, you need to declare a structure variable. Just like when you say in your C program, struct student, then say the fields for structure student are, say ID is 5 symbols, and then after the ID, a student has a name, say for example 15 characters. And what other fields should there be for structure student type? A student has ID, a student has name, and it has course. Say for example, course is 10 symbols, a string of 10 symbols. So ID is a string of 5 characters or 5 symbols. Name is a string of 15 characters or 15 symbols. And course is a string of 10 symbols or 10 characters. And then year level. So year level is type integer. This is 1 if the student is first year. This is 2 if the student is second year, and so on. And another field for structure student is grade, which is maybe type float. And then say we only have 1, 2, 3, 4, 5 fields for structure type student. So we call this as structure type definition or declaration. Now, the structure type name is student. It is a type name. The structure type name student has no memory allocation because it is simply a definition. Okay, it is not an actual variable that occupies memory space. We could declare a structure variable this way using the keyword struct, and then we declare the structure type name student and say S. So S here is a structure variable. Being a variable, it has memory allocation. It is allocated memory spaces. What is the difference between S and student? Student is a structure type definition, no memory allocation, while S is a structure variable which has memory allocation. And being a variable, we can assign values to this. Structure variable S is actually a group of variables which are s.id, the student's name, s.name, so you can assign student ID, say for example 2019-001, and say s.name is Juan Cruz. So we have also s.course up to s.grade. A structure is like a student record consisting of these variables. So in a way, a Java class is analogous to a structure type definition, while an instance is analogous to a structure variable. So the class is like a model, while the entity is an actual thing based on the model. A class can interact with another class. A class method can be called by other classes, and a class field can be accessed by other classes. So as you can see here in the figure, we have class A interacting with class B. Class B has some fields and some methods. Again, the fields of a class are those representation of the object's states, and the methods of a class are those representation of the behaviors of the object that the class is representing. So this class A can call or access the fields and the methods of this class. So to interact with another class, one class has to call or access a method or a field of another class. Say for example, this one class is A, the caller, and B is the called class. When we say that B is a called class, it means that A, class A, the caller, will access or call the methods and the fields of the called class or class B. So to do that, first create an instance of another class. Okay, so create an instance of another class. Say this instance of B is this one. And second is to call or access a method or field of that instance. Now, the process of creating an instance of another class is called instantiation. In the Eclipse IDE, we have here two Java classes. First Java class is student. This is our class B, the called class. Okay, so say this is our class B, the called class. And class B has 6 fields. These are the fields of class student. And there's only one method of this student class, and this method is compute grade. And the second class we have here, which is the caller class with the name student assessment, has main methods, so this can execute or this can run. Class A called class B, okay, student, this one, class B, student, first by instantiation. So again, the first thing to do is to instantiate the called class. Okay, so create an instance of the class that you're going to call. So this is how we instantiate the class student. So instantiation of class student is creating an actual student entity. So this Java class student is like a definition of a student, while S is an actual entity. S is called the instance. So student is the class type, while S is the actual student entity. So S is the instance, while student is a class type, a definition, while S is the actual student entity, which is the instance. So if you want this caller class to access the called class student, you need to first create an instance of that class. And then via that instance, you access all the fields and the methods. So you treat this one as a string variable. This is also a string variable. This one is also a string variable, and this is an integer variable, just as defined in here. Okay, year level is an integer variable. All the rest, ID to section, are string type, and grade is double type. So being variables, you could assign values to it by direct assignment, or you could assign values to these variables by user input. And then you could display all the values in here. In here, we call the method compute grade via the instance S, passing all of these values, parameter values, 78 being the grade of the student for the maybe class standing. This is the performance innovative task, 20%. This is the major exam, and this is the quizzes. So to instantiate a class, the syntax is this one. First, you specify the class name, like what we did here. We specify the class name student. And next, the instance name. And in our example, our instance name is S. And then followed by the assignment operator and the new operator. Followed by the whole thing here is called a constructor. A constructor is like a method call. Okay, a method call, or in C programming language, we call this a function call. In Java, we call this method call. So since it is a function or a method, it has some argument, and the class name is, of course, whatever is the class name in here. So this whole thing here is called a constructor, and of course, the instantiation statement is terminated by a semicolon. An example to that is this one. So this is the class name employee. the instance is emp, the new operator, and the constructor is this one. In our example here for student assessment, this is the class name of the called class, and this is the instance, and then this is the constructor. Now, a constructor is simply a special method, and it is a special method first because the method name is the same as the class name. And whenever you instantiate the class, the constructor is always called because the job of the constructor is to provide initialization to the class fields. If a class, like in this case, a class has no constructor, we did not explicitly create or define a class constructor. When we don't define a constructor in a Java class, the compiler will automatically create a class constructor. So this one is called a default constructor. So a default constructor looks like this. Okay, so this is called default constructor. But you don't have to explicitly create or define default constructor. You can omit that and the compiler will automatically create a default constructor if there is no constructor defined in a Java class. When accessing the fields and the methods of a called class via the instance, we use the dot operator. Okay, that is the convention used. After we have instantiated the class pet, creating the instance P. Okay, so P is the instance and pet is the class definition. So the class type of this variable or instance P is pet. This is instantiation and this is the constructor. What this constructor did is to initialize the name of the pet P as Jedi. After we have created the instance P, you could access the field this way, P dot name. So that is how you access the field. And you say P dot get name and then argument. Okay, so this is how we access a method. Instance dot and then the field. So the syntax is, this is instance and then dot field. To access a method, we use the syntax instance dot method. So to access a field, you use this syntax. To access a method, you use this syntax. Okay, examples to that is this one, p.name accessing a field and p.getName accessing a method. So in the same way here in our example, after we have created an instance S of class type student, we could access all the fields of the class type via the instance S. So this is s.id, student S ID, the ID of student S. This is the name of student S, the course of student S, section of the student S, and year level of student S. So S here refers to one student, and these are the specific description of that student S. So each student has ID, name, course, section, and year level. All of this refer to one student, and that student is S. To access a method, this is our example. Take note that compute grade is a method, just like a function. It has return type, method name, the arguments. It requires 4 parameters or arguments to be able to compute the student's grade with these percentages assigned to the 4 scores. And so when we call it here, to compute the grade of the student as having obtained these scores, then we simply call it by this method call s.computeGrade, passing the scores as parameters. So again, we use the dot operator. to access the fields and the methods of the instance.